Hi, this is Guntuka Srinivas. Welcome to Varenya's Photon Online Educational Academy for IIT and NEET examinations. In this channel, we mainly concentrate on the basic concepts related to physics, chemistry, and mathematics subjects required for IIT and NEET examinations. In this session, I welcome you all for the IIT physics classes. So in the previous session, we have seen some numericals associated with velocity. Let us see in this session some more numericals associated with the velocity. And if you like the channel, please share it and subscribe the channel. Let me take up the first problem. That is the first one. First problem. Displacement versus time graph is given. Find the velocity in the OA region. This is the problem. It says displacement versus time graph is given. Find the velocity, is interested in the velocity in OA region. The OA region. And the graph is provided is, this is the graph. On the x-axis time, t in seconds. Here, in seconds. On the y-axis, displacement, yes, in meters, is given. And graph provided is, this is the graph, OA line. And observe, these are the dotted points that are given. So on the y-axis it is 12, and on the x-axis also it is 12. That means at the point A, which is the line intersecting the y-axis, 12 meters indicating, since y-axis is meters. And at point A, perpendicular drawn onto x-axis, 12 intersecting, that is 12 seconds, that is the time. Now it requires velocity in this case. Clear? Let us solve this problem. Given graph. What is the graph? This is x-axis. This is y-axis, origin. So this is the line, A point. Here, no. These are the dotted lines showing. And be careful. Here, S is displacement, T is time. It is in the meters, bracket I am writing. It is in the seconds. Here, S versus T graph is provided. So S versus E, S transfer versus T graph. S versus T graph is given. we simply say ST graph. ST, not S minus, it is ST. ST graph. ST graph is provided. Clear? Okay. Now, it requires velocity. What is velocity? Slope of displacement versus time graph is velocity. Here I clearly write slope of S versus time graph is nothing but velocity. Slope of S versus time is nothing but velocity. A simple definition. Clear? Now, observe here. What is the slope? So, in the previous session, we have seen that is slope is equal to slope of ST graph is equal to y2 minus y1 by x2 minus x1, slope of that. That means in this case, S2 minus S1 by T2 minus T1. This is nothing but slope of graph. Slope of graph is y2 minus y1 by x2 minus x1. Okay. Now, observe. This is the graph. S, T, origin, here, A point, and these are 12. This is also 12. Clear? What are the coordinates? What are the coordinates of A? Coordinates of A is x coordinate is, observe, yes, x coordinate is T, y coordinate is S. What are the coordinates? 12. X coordinates. Y coordinate is also 12. Similarly, origin is 0, 0. If I say origin as x1, y1, x1, y1 origin, and A as x2, y2, x2, y2. For OA region, slope of for OA region, slope is y2 minus y1. Y2 is how much? 12. Minus y1 is 0. 12 minus 0 by x2 minus x1. x2 is what? Again 12. x1 is how much? 0. 12 minus 0 by 12 minus 0. 12 by 12. So, this is equal to 1 meter per second. Slope is nothing but velocity. Slope of ST graph is nothing but velocity. Slope of ST graph is nothing but velocity per OA region. Okay, simply find out the slope. Slope is find out the coordinates of the points in between x2 minus x1 and y2 minus 1. That is the slope. Slope of that region itself is velocity per displacement versus time. Okay, let us take up the second problem. This is the second problem. Okay. S is equal to 3t square plus 6t plus 9 is given. Find velocity. At t is equal to 3 seconds is equal to 3 seconds. That was problem. Observe, relation is given. S is equal to, this is the relation given to you. S is equal to, this is the relation given. Okay. Now E is asking at a particular time t is equal to 3 seconds. That means instantaneous velocity requires. What is the instantaneous velocity formula? V bar instant is ds by dt at a particular instant. Differentiate it this term. When I differentiate it, 3 into t square differentiation 2t plus 6 into differentiation of t is 1 plus differentiation of constant is 0. So this becomes 12t plus 6. 12t plus 6. Yeah. T square differentiation is 2t. T differentiation is 1. Constant differentiation is 0. So 60 plus 6 is the instantaneous velocity. But it requires a t is equal to 3 seconds. A t is equal to 3 seconds. Substitute in place of t 3 seconds. Clear? So yeah, v instant, what we obtain? 12t plus 6. 12t plus 6. So at t is equal to 3 seconds. At t is equal to 3 seconds. V instantaneous is 12 into, in place of t, 3 seconds. You have to substitute 3 plus 6. 12 3 is 36. 36 plus 6, 42. 42 meter per second. The answer. 42 meter per second. Is it clear? Okay. Let us take up another problem, that is the whatever s is equal to 2t square plus 90. 2t square plus 90. T square plus 90. Find average velocity in between t is equal to in between t is equal to 2 seconds and t is equal to 4 seconds. In between t is equal to 2 seconds and 4 seconds. Relationship is 2t square plus 90. He requires average velocity. Be careful, average velocity. So observe. S is what he has given, 2t square plus 90. This is the relation given. Relation given is this. Okay. Now, average velocity formula is what? Average velocity is V bar average is change in displacement by change in time. Change in displacement from where to where it requires. Okay, if I draw a line here, this is the path of movement. If origin is the starting of journey, let us say that t is equal to 2 seconds and t is equal to 4 seconds. T is equal to 4 seconds. So origin to up to this point, I am giving a point B name. This point I am giving as A name. Origin to up to B, t is equal to 4 seconds. If displacement is S2. And origin to up to A point, if displacement is S1. Displacement is S1. Then in between 2 seconds and 4 seconds, what is the displacement? In between 2 seconds and 4 seconds, displacement is S2 minus S1. So this means S2 minus S1. In between A and B, what is the time change? If I take it as T2, I just take it as T1. So T2 by T2 minus T1. T2 minus T1. The formula. Okay. Now, observe. So here, S is equal to 2T square plus 90. So S2 we require. S2 is displacement at T is equal to displacement at T is equal to 4 seconds. Substitute here. In place of this T, substitute 4 seconds. So 2 into 4 square, T square, 9 into 4, so 16. 4 into 4, 16 into 2, 32, plus 9 4s are 36. 16 2s are 32 plus 36. So 68 meters. 68 meters is S2. Similarly, S1. S1 is what? Displacement at T is equal to 2 seconds. T is equal to 2 seconds. Substitute here in place of T, 2 seconds. 2 square plus 9 into 2. So 4 into 2, 8 plus 9 into 2, 18. 18 plus 4 into 2, 8. 9 into 2, 8. 18 plus 8, 26 meters. So observe, I am highlighting. S2, displacement at T is equal to 4 seconds is 68 meters. S1, displacement at T is equal to 2 seconds is 24 meters. S2 is 68 meters. S1 is 26 meters. 68 and 26 meters. Clear? 68 and 26 meters. So V average is S2 minus S1 by T2 minus T1. So that is 68 meters minus 26 meters by T2. T2 is how much time? 4 seconds. And T1 is 2 seconds. Okay. So observe, this is 42. 68 minus 26 is 42 by 2. So 21 meter per second is the average velocity. Average velocity. Clear? So these are the simple numerical problems associated with the velocity. Clear? So if you like the video, please share it and subscribe the channel. Thank you very much.